All right. We'll go ahead and get started. It's Friday, week 10, our very last lecture. Thank you all for being here. And I appreciate seeing you guys. I appreciate no, genuinely thank you for a great quarter. And yeah, I'm I'm looking forward to summer break. I imagine you guys are as well. Um, wait, maybe I asked this, is this anybody's like last quarter ever at UCLA? Like you're graduated, you're done? Okay. All right. No, that's okay. But all right. Well, um yeah, summer's right around the corner. Okay, so today we'll spend some time doing review. These ones are going to be more kind of calculation type problems, setting up the hypotheses, finding your p-values, making a conclusion. Um, Again, as far as the conceptual practice problems, of which you can expect probably out of the 50 questions, about 20 of them will probably be conceptual and 30 will be about kind of like this. So for the conceptual ones, I would say use the AI prompt that I provided. And then another thing you can do is, the thing about the AI prompts is you can customize them to things that you want to emphasize. You can also upload any of my notes to the AI as well and ask like, please make conceptual questions. You can ask it to like make the wording tricky on the distractors, things like that, to try to, fine tune um, your understanding. Now, just a caution, sometimes the AI does make mistakes. But I mean, that's the same concern that could happen like if you hire a tutor, right? You hire a human tutor, most of the time they do a good job. Sometimes they do make a mistake, or sometimes they do something that's a little bit different. Uh, but overall, I think it does a pretty good job. But okay, anyway, we'll work through this. I've posted this PDF. I will write the answers on the screen here, and then whatever I don't finish in class today, I'll post the remaining solutions as well. Okay. All right. So it starts off with a community college's tutoring center wants to know whether more than 45% of first-year students use free tutoring at least once during the term. A random sample of 160 students includes 84 who use tutoring at least once. Okay, so does the sample provide evidence that the population proportion is greater than 0.45? So here, the key is we are working with proportions. And how many samples do we have? Okay, we have one sample. And we want to, because we're testing to see if something is greater, we're going to do a hypothesis test. So our answer here is going to be a z-test for one sample proportion, okay? This one is wrong because of the mean. This one is wrong because of 2. A confidence interval could be used, but because we're asking, I would say because of the greater than sign there, we want to do a hypothesis test. Okay, what are the hypotheses? So we want to check against 45%. That's kind of the key here. So null hypothesis always has an equal. Alternative, we're going to have greater than 0.45. Okay, so we're going to put in P and P equal to 0.45. So these are wrong because of the hat. This is wrong because of the not equal sign. I mean, the less than sign. This is wrong because of mu. So our correct answer there is A. I think I might have left everything at A. Okay. So as far as our standard error, we use the value from the null hypothesis. P0 times 1 minus P0 divided by n. So we're going to put in square root of 0.45. 1 minus 0.45 divided by our n here is 160. Take the square root of that. Get a standard error of 0.0393. Okay. My p hat is 84 divided by 160. So I get 52.5%, 0.525. So my z-score, p hat minus the p from the null hypothesis divided by standard error. Okay. I get a z-score of 1.91. So we are expecting 0.45. Here we are at 0.525. And we're shading everything to the right of that. Okay. So our correct answer here, also A. Okay, and then so we're going to look up z equal to 1.91 and find the area to the right of that. So going to our z table, we have 1.91, 0.9719. That's the area to the left. So this side is 0.97. Wait, sorry, what was it? 9719. It's going to be 0.0281. Okay. And if this is our p-value, this is less than our significance level. P-value is less than alpha. So that means we are going to reject the null hypothesis. Okay. So here, rejecting the null means we do have enough evidence, the sample provides evidence that more than 45%, so basically we can reject this, and then we have evidence to support this, right? reject the null, evidence to support the alternative. So we have evidence to say that the proportion is more than 45%. Okay. We don't like the word proves. We don't like to say exactly. Okay. This is the wrong direction. And then does not provide evidence. That would be the case if we does not provide, but this because 84, that's wrong. Okay. Okay. Can I move on? Next problem. And I'll post all of this up. I'll share all of this. Okay. Next one says, a farmer's market wants to estimate the proportion of customers who bring you reusable bags in a random sample of 250 customers, 148 brought reusable bags. Let's make a 95% confidence interval. Okay, so we've got a p hat, and it is 148 divided by 250. 0.592. Okay, we are making a 95% confidence interval, and we are dealing with proportions. So we can get rid of these ones. We can get rid of this one. So we're not doing a test, and we're making a confidence interval. We're not dealing with mean, so it's a confidence interval or one sample proportion. Okay, the point estimate is our p hat, and this is the only one that's correct. We are not looking at, these are all wrong. X bar, okay. This is, I guess this is 1 minus, but that's not the case. Our standard error is p hat times 1 minus p hat divided by n. So this is important to remember. When you're doing a z-test, you're using p0 in the standard error. And for confidence intervals, you use p hat, okay? So confidence interval uses p hat in the standard error. Hypothesis test, you use the p from the null hypothesis. Because whenever you do a hypothesis test, it's under the assumption that the null hypothesis is true. All right, so plugging in our values, 0.592 times 1 minus 0.592 divided by 250. What is 0.408 divided by 250? Square root of that, 0.031. Okay, so now we have p hat plus or minus 1.96. This is 95%. Okay, 1.96. So you'll need a few values. 95% is 1.96. 90% is 1.645. Put these on your note sheet. 80% is 1.28. And 99% is 2.58. I think these are in one of your notes, or you can memorize them. This is not necessary to memorize. Okay, times are standard error, p hat. So our p hat is 0.592. Let me just. So we're basically adding around 6%. So 0.031 times 1.96. Yeah, 6%. 0.592 plus or minus 0.061. So on the low side, I get 0.531. And on the lower bound, and the upper bound, 0.592 plus 0.061, 0.653. So I'm 95% confident that the proportion of people who use reusable bags is somewhere between 53 and 0.653. Okay, yeah, that's actually the first one there. We're not talking, okay. We never use the word exactly. The interval means 95% of future samples. It's nothing about future samples. There's a 95% chance. We don't use the word probability or chance there, and it's also not about the sample proportion. Okay. So we like the word confident. It's always about the population proportion being between these things. Okay. Okay. What does this interval suggest about whether a majority of all customers bring reusable bags? Okay. So majority would be 50% or higher. And our entire interval, right? So 0.5 is outside the interval. And entire interval is above 0.5. Okay, so because the entire interval is above 0.5, the interval supports that a majority of customers bring reusable bags. Okay. These other ones are incorrect. The interval, the interval is not centered at 0.5, but that doesn't mean we can't make any kind of conclusion. Okay. 0.5 being not the same as 0.95 doesn't, this is irrelevant. Okay. If 0.5 were inside the interval, okay, so this is just kind of a side note. And if the interval was, say, like 0.45 to 0.56, okay, then it is plausible that the proportion is below 0.5. So we cannot conclude a majority use reusable bags. So here we're looking at 0.5 and whether our interval is entirely above 0.5 or not, or if 0.5 is somewhere inside the interval. So this is just a hypothetical. That's a possibility. Okay. I'll keep going. If you need me to slow down or have any questions, don't hesitate. All right. Here it says a clinic is testing whether text reminders increase attendance at flu shot appointments. Among 250 randomly selected patients who received a reminder, 145 attended. And then among 240 who did not, 120 attended. Does the data provide evidence that the attendance proportion is higher for patients who receive a reminder? Okay, so we have we have two samples here. Okay, we've got those who got the reminder, we've got those who didn't get the reminder. Okay, so we have two samples. So we will eliminate the one sample ones. Okay, and then anytime you're dealing with proportions, because here it's whether they attended or not, okay, we're going to do a z-test. Okay, so it's not means. All right, let P1 be the attendance proportion for patients who receive a reminder, and P2 be those who did not receive a reminder. Okay, so here we want to know who received a reminder, so that's going to be P1. Those who receive a reminder is P1 and P2. So what we want to see, our alternative, we want to see P1 being higher than P2. The null hypothesis always has an equal sign, so we're just going to do P1 is equal to P2. So that is the correct answer choice. The one here, where it's less than, that is incorrect. Here, don't use hats. No hats. And not mu. Not mu for proportions. Okay, our pooled proportion, so that's the proportion overall, also known as the pooled. So this is the total number. We're going to do n1 plus n2 in the denominator and x1 plus x2 in the numerator. So we have 145 out of 250. And now we're going to add 240 to the denominator and then 120. So in total, we have 265 divided by 490. Okay. And so 265 over 490. Oops. Is 0.541. And then the standard error, this is just this formula. You got to just plug the values in. 0.459 over 250, 1 over 240. This is 0.541 times 0.459 times parentheses 1 over 250 plus 1 over 240 square root 0.0450. Okay, yes. So that works. Our z-score is the difference between our p-hats, p-hat1 minus p-hat2 divided by our standard error. So I've got 145. I'm going to zoom in here. 145 over 250 minus 120 over 240 divided by 0.045. Okay, 145 divided by 250 minus Well, 120 over 240 is just 0.5, but that's fine. And we're going to divide by 0.045 and get positive 1.78. Okay, so the t being 1.78 is wrong because of the t. This is negative, so that's wrong. Okay, so it comes down to these. And here it's one-sided, okay? Because of the greater than sign, right? The question here is it higher? So is higher leads to a greater than sign, so that's going to be one-sided. So looking at this, we're at 1.78, and we want to find this area over here. So we will go to our reference tables, look up 1.78, 0.9625. That's the area to the left. This is 1 minus that. Point 0.0375. This is our p-value. Okay, so that gives us positive 1.78 for our z-score, positive 0.038 for our p-value. We would double this to 0.075 if it just said, does the data provide evidence that the attendance proportion is different? Okay, if it said different, we would use a not equal sign. Okay, so I'll just say if question do we have evidence that the proportion is different, dot, 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 then the alternative has a not equal sign, and then the p-value is equal to 2 times 0.0375, 0.075. Okay. So on the final exam, I guess be careful, pay attention. You will have the answer choice for one-sided and an answer choice for two-sided results. And depending on the question, you'll need to know and be able to identify whether we are looking at different or greater or less, things like that. Okay. So if my p-value is 0.038 and my significance level is 5%, okay, we are going to reject. So p-value is less than alpha, so that means reject the null hypothesis. Okay, so our conclusion is reject this, and we have evidence to support that. The sample provides evidence that text reminders do increase the appointment attendant proportion, so that's going to be A. Okay. And that's that problem. Okay. I think that's okay. I hope that's all right. Okay. A bakery labels its blueberry muffins as averaging 120 grams. A quality control worker suspects the average muffin weight is less than 120 grams. And a random sample of 16 muffins has a mean weight of 116.8 grams and a standard deviation of 6.4 grams, right? It's kind of like on the nutrition facts. One serving size is one muffin, 120 grams. What if that was a lie? Okay.
Does the sample provide evidence that the bakery's muffin averaged less than 120 grams? Okay, so here we are dealing with means. Okay, how many samples? 16. You just say, how many ends do I have? I only have one sample of 16. Okay, so, and because we're checking to see if it's less, we're going to do a t-test. And less, this is also going to mean it's a one-sided. Okay, so t-test, one sample mean. It is not z-test. It's not proportions. We don't have two samples. I suppose a confidence interval could be done, but we wouldn't really use a confidence interval for testing it against some kind of qualified value here. So our null hypothesis is that the mean weight of the muffins is 120 grams. The alternative is that the mean weight is less than 120 grams. Okay. Don't use X bar. Okay. Always use mu for population. Okay. This is the wrong direction. Okay. This uses P, which is for proportions. These are wrong. Okay. Standard error. S over the square root of n. Our degrees of freedom is n minus 1. So it says our standard deviation is 6.4. We're going to divide by the square root of 16, which is our sample size. 6.4 divided by 4, that's 1.6. We have 16 minus 1, 15 degrees of freedom. So that's correct. Okay. This is like trying to use proportions. That's not right. Okay. This one is missing the square root. And this has the wrong n. It's using, that's the X bar, not the sample size. Okay, our test statistic is going to be X bar minus the mean from the null hypothesis divided by our standard error. Our sample mean was 116.8. Our null hypothesis says it should be 120, and our standard error was 1.6. So this is our diagram. We're going to put 120 in the center here. We've got 116.8 over here, and we just want to shade the area to the left of this. So our T, 116.8 minus 120, I think that's negative 3.2. And we're going to divide by 1.6. So I get a negative 2.0. Okay. So we will eliminate this one, and we'll eliminate that because it says Z. And now we have to look up negative 2 in the T table. With degrees of freedom equal to 15. So I go to our T table, 15 degrees of freedom, and we're looking for negative 2, or in this case, we're gonna have to switch over to positive 2 because it's positive values only. But 2.0 is in between here and here, which means my tail is between 0.05 and 0.025. Okay, so I don't have the exact number, but this is the only one. This is between 0.025 and 0.05. Okay. If we were to double it, then B would make sense. But here again, because it's a one-sided test, we're just trying to see if it's less than 120. We don't double it. So we're going to leave it at that. Okay. At the 5% significance level, what do we do? So our p-value is less than alpha. That means we reject the null hypothesis. We have evidence, okay, that the average muffin weight is less than 120 grams for shame. Okay. All right. There's nothing about proving. It's nothing about every muffin, just on average. Okay. Doesn't provide evidence. 116 is kind of close, but it is statistically significantly different. Significantly different. Okay. And greater is the wrong direction there. Okay. All right. We got a couple of these left. Oh man. Well, if you guys go through the exam at this pace, you'll be done really quick. All right. A campus wellness team wants to estimate the average number of hours that students sleep on weeknights. A random sample of 25 students has a mean of 7.3, standard deviation of 1.1. Team wants a 95% confidence interval. They also want to know whether the interval provides evidence that's different from 7. Okay, so it says confidence interval. So we're going to do a confidence interval. We only have one sample, okay? It's just the 25 students. So n is equal to 25. So that's one sample, confidence interval. Okay. We are going to have n minus 1 degrees of freedom. So that gives me 24 degrees of freedom. And for 95% confidence, we'll have to look this up. 24 degrees, 95% confidence is this column right here. We're going to use the number 2.064. Okay, standard error, S over the square root of n. Standard deviation is 1.1. And divide by the square root of 25. 1.1 divided by 5. It's going to be 0.22. Okay. The margin of error is t star times the standard error. Okay. So this is going to be 2.064 times 0.22. 0.454. Okay. So that's what we have there. So confidence interval x bar plus or minus t star times our standard error. So we have an average of 7.3 plus or minus 0.454. So on the lower bound, whoops, 7.3 minus 0.454, 6.8546, 6.846. And on the upper, we get 7.754. Okay. And we say I'm 95% confident the average amount of sleep is between 6.85 and 7.75. Okay. All right. Now we're looking, is it different from 7? Well, 7 is inside the interval. So the interval does not provide evidence that the population mean differs from 7 hours. Okay, it doesn't necessarily mean that it's equal to 7 hours, but we can't say that it's different. All right. The average, yeah, so this is 7.3 is greater than 7, but that's not how we make conclusions. All right. Confidence interval can't be used for mean. That's also not true. All right, so these are incorrect. Okay, this is the last practice problem we have. I think we'll get through it. Cafe compares wait times for 2 ordering systems during similar busy periods. 18 randomly selected kiosk orders. The mean wait time was 5.1 minutes, standard deviation of 1.4. 16 randomly selected counter orders. Mean wait time was 6.5 minutes, so the standard deviation of 1.8. Mu1 will be the wait time for kiosk. Mu2 will be the counter orders. Does the sample provide evidence that the kiosk orders have a lower average wait time? Okay, so lower, again, we've got a one-sided test. Here we have 2 samples. We have 18, this is going to be N1. 16 for the counter, that's going to be N2. So we have 2 samples. We're dealing with means. So it's going to be a t-test for 2 independent samples. Our null hypothesis, mu1 is equal to mu2. And then the alternative, if mu1 is for the kiosk versus mu2 the counter, and we want to know, does the kiosk orders have a lower average wait time? That's what we want to test. Okay. So these ones are wrong because they use P. These ones are wrong because of X bar. This one's wrong because of the direction of the alternative. Okay. Degrees of freedom, we're going to use n minus 1 using the smaller n. So we're going to have between 18 and 16, our degrees of freedom is going to be 15 degrees of freedom. Okay. And then the standard error is just this formula. Okay. S1 squared over N1 plus S2 squared over N2. So putting in the values, we got 1.4 squared over 18. And then standard deviation 1.8 divided by 16. 1.8 squared over 16. So these ones are missing the, ooh, something happened. Okay, so if I compute all this out, 1.4 squared over 18 plus 1.8 squared over 16, and then I take the square root of that, we get 0.558. And they round off to 0.56. Okay. Oh, something was weird about this. So our T. Okay. All right. I don't know what happened there. Okay, so we're going to compare our two wait times, 5.1 versus 6.5, divided by 0.558 or 0.56. 5.1 minus 6.5 divided by 0.558 or 56, and I get negative 2.51. So yeah, either of these are fine. T is negative 2.51. We're going to look this up with 15 degrees of freedom. So 2.51, 15 degrees of freedom. It's in between here and here. So my tail area is between 1 and 2.5%. 2.51 is in between this column and this column. So my p-value .01 and 0.025. Okay, so if that's my p-value at the 5% level, we are less than that. So we are going to reject the null hypothesis. The sample provides evidence that kiosk orders do have a lower average wait time. Okay. It says, all right, let's say we make the confidence interval. What does this suggest? Okay. And then similarly, because the entire interval is negative, 0 is not inside the interval. Interval supports a lower mean wait time for the kiosk orders. So both of in both these cases, answer A is the correct answer choice. Okay, I will post these answers up online for that. Good luck as you study, and we will see you on Monday for the exam. Thanks for a great quarter, everybody.